my latest project titled the AWS two-tier high availability project. So the diagram is architected such that you have the internet gateway which provides internet for the public subnet, and then the NAT gateway provides internet for the private subnet. The private subnet has the Auto Scaler which provisions the EC2 instances. So we have an Auto Scaler there with a minimum of 3 EC2 instances and a maximum of 10. On the public side, you have the load balancer, which will give access to the web application, and a jumper server on the public, which we would use to access the private subnet. That's the EC2 instances inside the private subnet. And we also have the Amazon EFS. The EFS is a network file sharing system within Amazon. So this is going to be mounted onto the EC2 instances in the private subnet and the jumper server, such that all the changes that were made from the jumper server will also reflect web servers in the private subnet. So let's jump in. So this is my AWS console. So let's start with the VPC. So I have a VPC created called the QBT VPC. So let's look at the route map. The route map shows QBT VPC with 4 subnets. So we have on the US East 2A, we have the public subnet. We have a private subnet there as well. On the US East 2, we have a public and this private subnet. So we have the public route table for the public subnets and the private route table for the private subnets. The public route table goes out to the internet through the internet gateway, which I called the QBT internet gateway, and then the private subnet's route table takes internet out through the NAT gateway. So that's basically our VPC setup. Let's also look at the security group. So I have 3 security groups created. We have the private SG and the public security group and the load balancer. The private security group is for the EFS and the private the EC2 instances that are going to be in the private subnets. The public security group is majorly for access to the jumper server, and then the load balancer SG is for the because the load balancer is going to be an internet facing load balancer. So we provisioned the security group to allow HTTPS access into the web application. So after that, what we did was to first provision our jumper server. That was the first thing we did. The jumper server runs on Ubuntu Linux, and so I have my scripts that I use. So we have a bootstrap script. This bootstrap script is a bash script. So what it contains is basically once the EC2 instance is created, it automatically renames the server to jumper server, do an update of the OS, do an upgrade. Then it creates this directory called home/ubuntu/web server, and then sets up the dependencies for the EFS mount, and then we'll now mount the EFS that was created, that's the EFS created in AWS, and then we'll now mount it. Then this is the API keys used to connect to the Datadog for monitoring. So this was done, and then we have the jumper server provisioned, currently running, and immediately that came up, we now have We go to our infrastructure. On the Datadog, you can see the jumper server showing up here. So it is actually being monitored. The launch template was also created using the bash scripts for our web server. Now let's look at the bash script for our web server. The difference between the bash script for the jumper server and the web server is majorly the installation of Nginx web server. So we do the same thing, change the host name, do an update and upgrade, then install Nginx, enable the Nginx service, and then start Nginx. Then this command here, sudo rmf, is to remove the contents within the www/html folder or directory. The sudo app install nfs tunnel, install the dependencies also for the EFS, and then the EFS is installed and mounted. Then this command here is to change the ownership of the var.www.h/html directory. It also connects the web servers to Datadog using Datadog API keys and the Datadog application keys. This is the script, and this script was generated from Datadog. So let me just show you how you can actually generate that script. So we can do this. We go to integration, click on install agents. Install agents, you select the platform you want to run Datadog. In this case, it's Linux. So we enable all of these features. Enable the ones you want. Most times we enable all of it. So infrastructure monitoring, enable it. Application performance monitoring, enabled. Observability, continuous profiling, enabled. Data stream monitoring, enabled. Cloud and application security, enable all of this. Then enable dot collectors, enable agents as well. So this now gives you a new API key. You can copy this. So this is where we get the scripts. You can copy this and bring it over to your scripts. And that is what we have here. This is how the script was actually generated. So we'll come back to your launch template. The launch template, you can create a new launch template, give it a name, give it the version. Is it for production? Is it for development or testing platform? You come to your quick start. The quick start here, you can select the OS you want to use. Is it Ubuntu? In my case, I use Ubuntu, and then you select the version. And I usually will use version 24.0 for LTS. You select your key pair. So I already have a key pair created. You can create a new one if you want to. On the network settings, you leave it at that. You don't touch the network settings. You can also the security groups. Select your security group. In this case, we're selecting the private security group because the EC2 instances that we created from these templates will be in the private subnets. Then we go to the advanced. So you now copy and paste your bootstrap configuration. All of this will be copied and pasted, and that is how you get your launch template. So we already have a launch template here called my temp. Next is to go to auto scaling group. Within the auto scaling group, while creating this, you create your target group and your load balancer. So just to open this, you see what we already have. So we have the desired capacity 3, scaling between 3 to 10. Currently it's at desired capacity. This is the key pair for our two instances that will be created. On the network side, you can see we have two availability zones. So it's US is 2A and 2B, and these are the subnets. These are the private subnets that are tied to this. If you go to the load balancer, we already have a load balancer called QBT Web Server. It's internet facing. Click on it, you can see the DNS record. Now, this is how we're able to create. The moment this was launched, it created 3 instances. So this 1, 2, 3 are the 3 web servers running behind the load balancer. The load balancer is our domain name, which what we have done is to create a record for the load balancer. So on the Route 53, on Route 53, you see we have a hosted zone. The hosted zone for qbtresource.com. So for qbtresource.com, this is the record. So we have an A record. Now this is the, so just to show you, this is the DNS record, QBT web server, that is the A record, which we've used to create this A record within the hosted zone in Route 53. And then we also created another record, a record called app. Okay, yeah, this is the A record, app.qbtresource.com. Assign the certificate to that domain name. So from the Certificate Manager, AWS Certificate Manager, you will see the list of certificates that has been issued. This certificate was issued to app.qbtresource.com. So with this, if you go to app.qbtresource.com, you'll see that the certificate issued there. Certificate issued is Amazon certificate. Now let's go back to the monitoring. So we have on the infrastructure side, like I showed you earlier, there are 4 hosts being monitored. 3 of them are the web servers and 1 is the jumper server, all being monitored. Then integration of Slack to Datadog. If you come to integration, go to integration, click on integration, you will see all the integrations that are available. So you can search here for Slack. You can just click search for Slack. But for us, you can see that Slack is already installed. And while it was being installed, we connected it to a public, a private channel. So we've already created a Slack workspace called Cloud Expert. Inside the Cloud Expert, you have channel created. I created 2 channels, security ops and monitor server. So the monitor server is what we want to use, and that was already integrated to the Slack here in Datadog. So you can see both channels are showing up here in Datadog. You can see we have Cloud Expert. Inside the Cloud Expert in Datadog, there you have monitor servers and security operations. Within the Slack channel, we've done some tests to test notifications from Datadog to Slack. And these notifications were set from this place, what this project entails, and we have an application currently running.